Dear friends, welcome to my video on what is the relationship of quantum mechanics and quantum computers. Kindly click on the CC button for subtitles. Quantum mechanics and quantum computers are intricately linked, with quantum mechanics providing the essential theoretical framework that makes quantum computing possible. Understanding this relationship is crucial for grasping how quantum computers work and why they represent such a significant leap from classical computing. The foundations of quantum mechanics. Quantum mechanics is the branch of physics that deals with the behavior of particles at the smallest scales, such as atoms, electrons, and photons. Unlike classical physics, which governs the macroscopic world and is predictable and deterministic, quantum mechanics is probabilistic and counterintuitive. It introduces concepts like wave-particle duality, superposition, and entanglement, which defy our everyday understanding of reality. Superposition, the power of multiple states. One of the most profound principles of quantum mechanics is superposition. In classical computing, bits represent either a 0 or a 1. However, quantum bits, or qubits, can exist in a superposition of states, meaning they can represent both 0 and 1 simultaneously. This ability to exist in multiple states at once allows quantum computers to process vast amounts of data in parallel, giving them an edge over classical computers in solving certain complex problems. Entanglement, linking qubits for exponential power. Entanglement is another key quantum mechanical principle where two or more particles become interconnected in such a way that the state of one instantly influences the state of the other, regardless of distance. In quantum computing, entanglement allows qubits to work together in ways that classical bits cannot, enabling quantum computers to perform multiple calculations simultaneously. This phenomenon is what gives quantum computers their potential to solve problems that would take classical computers millions of years. Quantum tunneling, exploring multiple possibilities. Quantum tunneling is a process where particles pass through a barrier that would be insurmountable according to classical physics. In the context of quantum computing, tunneling allows qubits to explore many possible solutions to a problem at once. This property could be harnessed to solve optimization problems more efficiently than classical algorithms. How quantum mechanics enables quantum computing. The principles of quantum mechanics, superposition, entanglement, and quantum tunneling, are not just theoretical concepts, they are the building blocks of quantum computing. By harnessing these principles, quantum computers can perform tasks that are practically impossible for classical computers. Speed and efficiency in quantum computing. The ability of quantum computers to process information in parallel, thanks to superposition, and to solve complex problems quickly, aided by entanglement and tunneling, is what sets them apart from classical computers. For example, in cryptography, a quantum computer could potentially break encryption codes that are currently considered secure, thanks to its ability to perform many calculations at once. Similarly, in fields like medicine, quantum computers could analyze vast datasets to discover new drugs or treatments more efficiently. The ongoing development of quantum computers. Quantum computers are still in their infancy, with researchers continuously working on overcoming significant technical challenges. For instance, qubits are highly sensitive to their environment, which can cause errors in calculations. However, advances in quantum error correction and the development of more stable qubits are steadily bringing the promise of quantum computing closer to reality. Quantum mechanics, the driving force behind quantum computing. In conclusion, quantum mechanics is not just a theoretical curiosity, it is the foundation upon which quantum computing is built. The unique properties of quantum mechanics, superposition, entanglement, and tunneling, are what enable quantum computers to potentially outperform classical computers in specific tasks. As research in quantum mechanics progresses, so too does the potential for more advanced quantum computers, which could revolutionize fields ranging from cryptography to artificial intelligence. The relationship between quantum mechanics and quantum computers is one of cause and effect, with the former providing the principles and the latter embodying their application. Understanding this relationship is key to appreciating the transformative potential of quantum computing in the coming decades. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.